Globalization has opened the doors of economic development for so many countries. There is a serious concern regarding how far we are being able to save the environment without hampering its constituents. India holds world's second largest road network in terms of length. Roads are considered as lifeline of the nation and an important prerequisite to accelerate economic growth.
Roads serve as the lifeline of trade and economy. India holds world's second largest road network in terms of length. Besides that, under Government of India's ambitious road development program such as Bharatmala and National Highway Development Program, massive road development will be carried out in upcoming decades.
Iron and steel industry are pillars to a country's economic and infrastructure development. India produces about 110 million tons of steel annually and poised to achieve 300 million tons steel production by 2030. Along with steel, about 19 million tons of steel slag is generated every year during the refining process of steel from different steel plants situated across India. For every ton of steel produced, about 20% steel slag is generated. Most of the slag are dumped in the nearby areas of steel plants, which becomes the source of water, air and land pollution.
Steel slag is a major waste of steel industries. Currently, the total steel slag of different steel industries is around 19 million tons, which is expected to grow to 60 million tons per year in the year 2030. So CSR CRI has taken up this R&D project sponsored by Ministry of Steel along with the 4 industrial partners: ArcelorMittal Nippon Steel India, Tata Steel, JSW Steel, Rashtriya Ispat Limited, to develop steel slag road technology, where the steel slags of different blast furnaces are processed for the development of steel slag aggregates, which is used for road construction.
Every year, multi-billion tons of natural aggregates are used in the construction and maintenance of road network in the country. The idea of environmental conservation gains real momentum if we can conserve natural resources and use them in a manner that they are sufficiently available for the coming generations as well.
ArcelorMittal Nippon Steel India, under CSIR CRRI technological guidance and supervision, has shown that processed steel slag aggregates can be used for construction of durable roads, thereby providing a cost-effective and eco-friendly green alternative to conventional road construction materials.
Steel slag, which is rich in iron content, can become the source of good quality steel slag aggregates for potential utilization as substitute of natural aggregates in road construction. Despite that, a large amount of steel slag generated from steel industries is disposed of in stockpiles today. As a result, a large area of land is being sacrificed for the disposal of this useful resource. The concept of sustainable development thereby comes into play.
Utilization of processed steel slag aggregate as substitute of natural aggregates in road construction has shown quite promising results. Recently, CSIR Central Road Research Institute along with ArcelorMittal Nippon Steel India has constructed a 1 kilometer long 6-lane bituminous road at Hazira, Surat using processed steel slag aggregate.
Iron ore is sourced from mines and sent to steel plants for first making iron out of it. In the form of pellets, sinter or lumps, the ore is reduced in blast furnaces or DRI plants to form hot metal or sponge iron. This is a raw material for steel making process. During steel making, flux is added to catch the impurities present in iron during the primary refining process. The flux along with impurities form a semi-molten mass called slag that floats on the liquid steel in the steel making furnace. Slag is a mixture of oxides formed by silica, alumina, calcium, magnesium and iron predominantly. The purified metal is taken out from the bottom and slag is taken out from the top of the furnace. The molten slag at 1500 to 1600 degree temperature is poured into the slag pits for cooling. A customized cooling process is developed by CRRI to control and develop microstructure to slag that work as stable aggregates. Once cooled, the slag is crushed into smaller sizes. Large chunks are broken by balling crane where large steel balls are dropped on the slag boulders to break them down. The finer slag is then passed through a metal recovery unit where large magnets separate the entrapped metal pieces in the slag. The non-magnetic slag is then crushed and screened to various sizes based on application. Quality of the aggregate. X-ray diffraction analysis of processed steel slag aggregates is carried out for mineralogical phase identification and compositional analysis. Processed steel slag aggregates developed through controlled cooling process shows the crystalline phases as found in good quality natural aggregates obtained from igneous rock groups. Chemical composition of steel slag aggregates in oxide form is determined through wave dispersive X-ray fluorescence spectrophotometer. Processed steel slag aggregates are also tested using inductive couple plasma mass spectrometry to rule out the possibility of any heavy metal leaching under adverse environmental conditions. TCLP study conducted using ICP-MS technique showed that processed steel slag aggregates are safe for various road applications. Physical and mechanical characteristics of steel slag aggregates are established through a variety of tests to assess its suitability as road construction material. The CSIR, Central Road Research Institute Research Laboratory used world-class testing facility for aggregates testing. Its most important properties are grain size distribution, resistance to crushing, abrasion and polishing. The volumetric stability of the slag is also verified by an expansion test. Mechanical characterization of asphalt mixes prepared using processed steel slag aggregates are carried out through the state-of-the-art testing facility comprising Marshall stability, indirect tensile strength determination, and rutting resistance. Brazilian modulus of steel slag asphalt mixes is also determined to design the steel slag road for different axle loads and traffic conditions. Scientists at CRRI have investigated the use of steel slag as an aggregate for bituminous road construction. The best management option for this byproduct is its recycling as road-making aggregate. In India, Surat has become the first city in the country to get a processed steel slag road built as part of a joint venture project between CSIR, Central Road Research Institute CRRI, Union Ministry of Steel, Government Think Tank Niti Aayog and ArcelorMittal Nippon Steel India at Hazira, Gujarat.
Around 1 lakh ton processed steel slag aggregates has been utilized as a 100% substitute of natural aggregate and good earth for construction of this road. This road connects NS6 to Hazira port and subjected on heavy commercial traffic. For last 1 year, CSIR CRRI is monitoring its performance and we found that this steel slag road is meeting all serviceability parameters as specified for national highway in India.
Processed steel slag aggregates offers better mechanical load resistance, leading to reduction in thickness of various road layers. Steel slag road at Hazira is built with 32% reduced thickness for 100 MSA design traffic and 20 years design life period.
ये जो रोड का निर्माण हो रहा है जो धातु मल से स्लैग से कॉस्ट वाइज भी अगर देखिएगा तो 32% 34% कम अभी है और आगे अगर और रिसर्च होगा तो 40% तक पहुंच जाएगा। इसकी जो ताकत है जो इसकी शक्ति है वो भी जो हमारे और रोड बनाए जाते हैं उससे बेटर है।
And I believe that we must look at alternative forms of steel making, such as making steel from steel scrap, such as the example that we have seen of the 6-lane highway that was built with steel slag in Surat in Gujarat, the first of its kind in the world. And that happens only in India, made in India, ladies and gentlemen.
Structural capacity of steel slag road is determined through heavy weight deflectometer test. Vertical surface deflection response of steel slag road under variable impulse loads are recorded through set of geophones. Surface deflections in steel slag road under identical impulse loading conditions are found to be 60 to 70% less than the deflection observed in conventional bituminous road. Temperature effect. Steel slag road is not expected to have higher surface temperature during peak summer time. CSIR-CRRI monitored the surface temperature of steel slag road and found that the surface temperature of steel slag road is as equivalent to conventional bituminous road. Benefits. The utilization of waste steel slag for road construction reduces pollution created by heaps of waste dumped near steel plants. The particles of steel waste also get into the air and even seep into the ground, reaching the underground water table.
For construction, maintenance and rehabilitation of road network, huge quantity of natural aggregates are required every year. This demand is meted out through the unsustainable quarrying of natural aggregates in many areas, leading to desertification and other serious ecological and environmental impacts. I would like to congratulate CSIR-CRRI for developing this innovative solution for utilization of processed steel slag in the construction of a steel slag road, which not only reduces the environmental impact of this waste material but also preserves our ecological system by meeting out the partial requirement of the natural aggregates.
The CRRI will now prepare guidelines and specifications for the utilization of steel slag in road construction. The parameters and performance indicators will be incorporated in the road guidelines and will be given to Indian Road Congress, Ministry of Roads and Highways to utilize steel slag for the constructions of national highways.
This technology has been used by CRI for construction of roads in Surat, Gujarat, in Jamshedpur, Jharkhand and Dolbi, Maharashtra.
Utilization of steel slag as substitute of natural aggregate in road construction is a green initiative under the Government of India flagship program Clean India Mission and Waste to Wealth.
Research has shown the possibility of using steel slag in road infrastructures in order to promote the objectives set out by the Sustainable Development Goals to promote the circular economy and sustainable infrastructure. CSIR-CRRI's innovative first steel slag road in Surat, Hazira has further motivated us our vision for a greener India, for a sustainable India, for a rising India. Steel slag road. A sustainable green utilization of steel slag in road construction.